Okay, we are on section 2.2.2 and we are going to venture into a slightly different topic. We're going to explore areas of shapes today, but it's areas of composite shapes. So composite means we're putting shapes together so that it's not just one rectangle or just one triangle. We're kind of putting together multiple triangles, multiple rectangles, or take some parts out of the other. All right, so if we take a quick look at number 2-70 here, it says, examine the variety of shapes below. Find the area of each one. If the shape has shading, then find the shaded area only. All right, so when I look at part A here, part A is actually looking like a rectangle, actually two rectangles together. So usually this is why I tell students, you have to figure out how to cut your rectangles, cut it into pieces, right? And again, the way I cut it may not be the same as the way you cut it. As long as we're getting the same answer at the end, it really doesn't matter how you approach it. So what am I talking about? You could cut your rectangle this way, and therefore you have a small rectangle and a large rectangle this way. Or if you don't like that cutting, you can cut this way, right, and have a small rectangle here and a large rectangle here. Again, up to you. There is no wrong way to do this as long as you're keeping track of how you're cutting this, right? So what am I talking about? I am actually going to approach it this way, just because, right? So what am I seeing here? I see that this long side was 5 feet. The little one dot means foot. 5 feet, and this side is 3 feet. That means then this little piece right here, that's only 2 feet. Okay, same thing with the little piece up there. So the whole piece 11 feet, and I have 8 feet here. That means then this piece right here must be 3 feet. Okay, so the small rectangle, actually let me try to do it this way. So the small rectangle is 2 feet by 3 feet. So it's this region right here. That's 2 times 3. That gives me 6 square feet. The big rectangle, I'm going to switch color now real quick. Big rectangle is this one right here. So watch out for what you're using as your unit, right? So the big rectangle, a large rectangle, has a base of 11 feet. So it's 11 this way, but it's only 3 feet up here, not 5 feet, just 3 feet. So it's 11 times 3 here, and that will give me 33 square feet. And now because this shape is a composite, it is a combination of the small and the large, so you need to add them together. So together you have 39 square feet. Okay, and that's it. That's it for part A. Okay. All right, part B, now it says it only wants a shaded region. So then the smart thing, the right thing to do would be to get the big rectangle and then cut out the small rectangle. So literally you take the big rectangle and you subtract, meaning cut away the small one in the middle. So I'm going to take the big rectangle, which is 24 meters by 12 meters. So 24 times 12, okay? And that gives me 288 square meters. And then I'm going to look at my small rectangle here, the blue one here. That's 4 by 8. That gives me 32 square meters. And now the difference is to subtract these two because you only want the shaded part. So you want to take the big one minus the small one. So you get, so this is a subtraction there, right? Well, please know it's a subtraction. You put a subtraction here somewhere so you know it's there. So it's a 256 square meters. That will be the total area for the shaded area. Okay. All right, so now let's look at the fact that we're not going to have numbers. We have these weird variables, right? So for any rectangle, it is, for the area, is going to be the base times the height. So in this case, base is x plus 4 and multiply by 2x plus 3. Okay, and so we need to multiply this out. You may have heard of FOIL if you like foiling. Some teachers don't really like foiling, so they like to call it distribution. Same thing, it's basically distributive property twice. So you distribute the x to everybody, right? So that gives me 2x squared, and I have 3x. And then now you take the 4 and also distribute it to everybody. So that gives me 8x plus 12. So you get a total area of 2x squared, combine your like terms, plus 11x plus 12. And that's it. There is no numbers for your area this time because you didn't start with numbers. You're not going to end with numbers, right? So you're going to have this variable like answer for your area. Okay. All right. So the next one is another composite. Looks like a steps, right? So you got to be a little bit more careful in terms of how you cut this. So what I see is I have this length of 27 centimeters, and it got cut into 1, 2, 3 pieces. And notice they all have the same tick mark. That means it's 3 equal pieces. That tells me then I take 27 and divide it by 3. That gives me 9 on each of these. Okay. Same thing on the other side. If I were to look at it and say, all right, there's 18 centimeters here, and then it got cut into 1, 2, 3, and they all have the same tick mark too. So it means divided by 3, that's 6 centimeters on each of them. Okay, now I can actually go ahead and start looking at each of the pieces, the area of each of the pieces, right? So the first piece here, if I were to cut it right here, that's a 9 by 6. That's 54. Okay, I can go ahead and write that there if I want. Then the next piece, okay, next piece is a little bit trickier here. Next piece, oops, sorry for running away. Next piece here actually has a base of 2 9s, so that's 18 times 6. All right, so 18 times 6, that gives me 108, right? 18 times 6 gives me 108, okay? And then the last piece here, last piece has 27 centimeters times 6, right? 27 centimeters times 6. So that gives me 42, 2 times 6 is 12, 162 there. All right, so now my total area is to add all those pieces up. So we'll take all the pieces and go, okay, I have 54, 108, 162. Add it up, I get 4, 2, 3, 324 square centimeters. And that's the total area for this weird step thing. Okay. Again, this is not the only way to do it, but it is one of the ways, and your answer should be the same as mine. Okay. All right, triangles. I'm not sure if you recall your formula for triangles, but triangle was area equals base times 1/2 base times height. Now, if you already know this, fantastic. But if you didn't know why it was 1/2, it is really because a triangle is always half of a rectangle. So if you look at this shape here, you have a rectangle that is the base of 14 yards by 5 yards. But notice I only want half of it because I only want the shaded part. So your area is a half of 14 times 5, which half of 14 is 7. 7 times 5 is 35. So you have 35 square yards. All right. Now, what if I don't have the rectangle like that? What if I have information like part F here? I have a triangle with the base kind of split up. So that's 4 and 10. So that's 14. I have a height of 5 inches here, right? So area is 1/2 base times height. I get 35, and this time it's square inches, but I still get 35. Interesting. So the next question asks you, the area for part F up here, for part F, must be the same as part E. Why? Why are they the same? Well, you may not have seen this, but if you already do, that's fantastic. But if not, bear with me. If I were to take this triangle here, okay, if I were to take this triangle and say, you know what, let's extend it out. Let's extend it out and make it, let me try to do a better job of this. Let's see. Okay, so let's extend the sides like we did in the previous one in part E, okay, and extend them out. Okay, so first of all, do you see that this is just the same triangle, but rotated and rotated over or reflected over so that it makes a rectangle that way. And then I'm going to do the same thing to the other side and kind of make it into a rectangle. So this is still a rectangle, and now this rectangle has a base of 14 because that's 4 plus 10, right? And it has a height of 5. So they have the same base and height in E and F. Even though they don't look exactly the same, the triangles didn't look exactly the same, but when we convert it into a rectangle, they are exactly the same in terms of the measurements. So both have 14 as a base, inches or yard, and then both have 5 as their height, inches or yard, all right? So how do we know? So both triangles are from half of a rectangle with base equals 14 and, equals 14 and height equals 5. Okay. All right. So again, because they have the same dimensions, it's going to give you that same exact thing. Okay. So do triangles with the same base and height have the same area, right? So look at this. In figure A, and again, you can use your ruler or your patty paper to see that figure A, this base is the same as figure B, same as this base, same as figure C, and same as figure D. They all have the same base. Now, height. What do you mean height? Because Miss Chu, they don't look right. Well, in the first figure, your height is this side right here because it's making a 90-degree angle right here. Remember, think about how you measure height at the doctor's office, right? You always have to stand straight with your back against the wall because the wall and the floor is going to make 90 degrees. No walls leaning, right? Even leaning Tower of Pisa, some walls inside are still straight, right? So if you stand straight like this is how you measure your height. So same idea with a triangle, you're looking for the height that is 90 degrees. So the height in figure B is actually right here. Here is figure B's height, right? Figure C, the height is actually right in the middle, and that is going to be the 90-degree height. Now, figure D is a little tricky. The height is actually outside. This is my height, right? I am pretending, again, if you're leaning something against the wall, the height, the true height is the purple line. You're going to have some distance to the wall, but still, that is the height that's making 90 degrees with the floor there. Your base is still only the blue area. So do all the triangles with the same base and height have the same area? The answer would be yes. All right, so if they all have the same base and height, they will all have the same area, okay? All right, so the area of any triangle must be 1/2 base times height. Okay, and that is a formula that we were going to use many times. So again, maybe you want to highlight this or remind yourself this is kind of important. Okay, area of a triangle. Okay, all right. So let's see if we can use that same idea to help us with next problems. How do you know which dimensions to use when finding the area of a triangle? So I briefly went over that in the previous problems there, but you are looking for the base and the height that makes 90 degrees. So in part A, the ones that make 90 degrees are, here's your base, 14 millimeters, and here's your height, 3 millimeters. That 5 millimeters on the side, that slant, doesn't do anything for us. It's just extra information. So the area of this will be 1/2 base times height, which gives us 21 square millimeters. Okay. All right. Now the second part, next problem here may be a little bit tricky, so you can turn your paper around if you want. But the only line I see with the 90-degree relationship is this line right here with this line right here. So one of them is my base, and it's the one back here. That's 5.9. That's my base, and my height is this 6.8 right here. So area must equal to 1/2 base times height. Okay, what about the 7 and 8? Those don't do anything for me. They're extra information there just to confuse you, to remind yourself that no, they're not bases or heights, because the base and height must make 90-degree angles. All right, and if you put this in or in your calculator or calculate this out, you should get 20.06, and the 2 marks means inches. So, means square inches. Okay. All right, last but not least, what if it's leaning like this? So we were talking about this before. So watch out though. Your base is only the part that's on the triangle. So the base is only 6 meters. My height is outside because that's the one that makes the 90 degrees. So that is your height. What about the 2 meters, Miss Chu? That's the distance from the wall to your object. That doesn't do anything. So it's kind of a pretend distance. That's why it's in dotted lines. So that doesn't count into your base. All right. So your area is going to be 1/2 base times height. That gives you 15 square meters. Okay. All right. So again, make sure you practice that third topic there with the triangle a little bit slanted that way, because it is going to be very important to remember that. Okay. All right. So let's see what else does it want us to do. Which numbers from each triangle did you use to find the area and why? So in the first picture there, I used 14 and 3 because the lines are perpendicular. It's the most important thing, right? Same thing in the next picture. In the second picture, we use 6.8 and 5.9 because, again, the lines are perpendicular. The last one's a little trickier, right? So I use 6 and 5. So not only, again, the lines are perpendicular, but only the base on the triangle. So I don't use the whole line on the bottom, right? So only the part that's on the triangle, only the 6 is my base, not 6 plus 2, not 8. Okay? So again, we're trying to hammer this in to make sure you really got the idea. So it says Mario, Raquel, and Jocelyn are arguing about where the height is for the triangle on the right. So here in this picture, so Mario says it's this line right here, Raquel says it's this line right here, and Jocelyn says it's this line right here. So which one should be the area, which one should be the height? Okay, so again, refer to that last picture we did. The height must be from the tallest point of the triangle and coming straight down, so it makes 90-degree line with an extended, a pretend base there. So the person who is right, Jocelyn. So Jocelyn is right. So why? Because the height must be from the highest point and, sorry, not to, and also perpendicular to the base, and sometimes it's an extended base. Okay? All right, so that is very important to have that to be an extended base, because again, your base is not long enough, so when it's slanted like that in an obtuse triangle, you're gonna have to extend it out and make sure you hit that baseline to make that 90-degree angle. Okay? All right. So when you get a moment, of course, you want to review this, how to multiply binomials, which is what I did before in the first, in the front of your notes on part C in number 2-70. Just kind of remind you how to multiply things out, how to distribute, but we'll definitely go over this in class, right? So this is part of your homework assignment and we'll go over that. Once again, don't forget to upload your completed notes for this section for 2.2.2 on Canvas when you are done. Okay, guys.